All right, here we go. We've got some ACT prep here. So we're going to start with 15. We're going to work our way all the way down to 32 as always. Remember that we need our TI 30 or TI 84 plus CE calculator. This is the best calculator for the ACT test. So let's take a look. What polynomial must be added to x squared minus 2x plus 6 so that the sum. So basically, I need to figure out what do I need to add to this thing to get me 3x squared plus 7x. All right, well, this isn't too bad because I need to figure out, all right, I got plus 6 right here. I need to get that to be plus 0. I've got no constant at the end, so I need that to be negative 6. So right away, if you're just doing some test, watching here, try to do some, be smart about it, that one's not going to work, or that one, or that one. So just left with 2. All right, well, they both have 9x, so I'm not going to worry about the middle one. So I'm going to take a look at this x squared into what is going to give me this 3x squared. All right, and that's going to be 2x squared. So it's going to give me, my answer is going to be D. When I add this plus that, I get my 3x squared plus 7x. All right, how are we doing tonight? Another day of ACT math prep. Remember, a little bit every day goes a long way. I didn't mean for that to rhyme, but that's a good point. Remember, same thing with your diet and exercise. All right, what is the slope of any line parallel to the line 8x plus 9y equals 3? So the question is, what is parallel? All right, so parallel are when two lines never intersect. A lot of times they're shown with these little arrows. So these are parallel. These lines will never intersect. So what I'm going to do is I'm going to go ahead and figure out the slope of this line. This is a linear equation. I'm going to find y equals mx plus b form. This is the slope-intercept form. What that allows me to do is find the slope, because we know slopes of parallel lines are the same. All right, that's huge. Slopes of parallel lines are the same. So now we may get somewhere where we have perpendicular lines. Okay, perpendicular lines, perpendicular, create 90-degree angles. Okay, 90-degree angles. And those slopes are opposite reciprocals. Remember that. Opposite reciprocals. So if one slope is 1/2, the other one is going to be negative 2 over 1. So let's take a look. This is 8x plus 9y equals 3. My good job is to get it into slope-intercept form, so I'm going to subtract the 8x. Do not add together the negative 8 and the 3. Huge issue there. They are not like terms. It's no bueno. So I've got 9y equals negative 8x plus 3. I'm going to divide everything by 9. See how I divided everything individually? That's key. So these 9s are going to cancel. I'm going to get y equals negative 8/9 x plus 1/3. So what I'm really looking for here is what is the slope? So if this slope is negative 8/9, I know that my parallel line is going to have a slope of negative 8/9. Letter G. All right, let's take a look at the next one. All right, we're rolling, aren't we? Here we go. In the standard xy coordinate plane, a line segment has its endpoints at 3, 6 and 9, 4. What are the coordinates of the midpoints of the midpoint of the line segment? So with this one, okay, it's looking for midpoint. Okay, midpoint is just simply if I've got 2 points here, I got to find that point that bisects the segment. So what I teach is I usually just take the average. Okay, so in this situation, I'm going to take the average of the x values. So my x values are 3 and 9. Okay, so 3 and 9. So if I add those together, I get 9 and 3 is 12. I divide by 2. So you add up how many things you want, and then divide by 2. So 9 plus 3 is 12. Divided by 2, I get 6. So right away, I know that these two aren't my answer because my x midpoint is 6. So if this is 3, 6, and this is 9, 4, The average between 9 and 3 is 6. So I'm going to go ahead and take the average of the y values. I got 6 and 4. 6 and 4, I add those together, I get 10. 10 divided by 2 is 5. So I take the average of the x's and the average of the y's. I get 6 comma 5. 6 comma 5. All right, we're on question 17. We did questions 15 and 16. We're going to hit towards question 34 today. We're going to get through 34. 2 pages a day keeps the math monster away. Remember that. All right. When y equals x squared, which of the following expressions is equivalent to negative y? All right. So let's say we let x equal 4. Okay. So if x equals 4, I've got y equals 4 squared. So I've got y equals 16. All right. So if I have 16 equals 4 squared, what happens if I put a negative in front of that 16? What would I have to do to this 4 squared to go ahead and make it equivalent to negative y? Well, that's just going to be to put a negative in front after I square the 4. So my answer here is going to be G. Like, this is not a problem that you've seen in algebra. They're just trying to get a grasp of your number sense. All right, so sometimes these problems are way kind of tricky, but honestly, they're very straightforward. They're just trying to make sure you got some good number sense. And if you don't, hey, that's why you're here, Math Be Real. So let's take a look at number 19. For the function h of x equals 4x squared minus 5x, what is the value of h of negative 3? All right, so this right here is called a function notation. So what this allows us to do is this allows us to name functions different letters, but also to go ahead and change the input. My input here is x. All right, so this function h takes whatever I have here, squares it, times it by 4, subtracts it from 5 times whatever is there. Well, now I'm going to go ahead and put negative 3 here. There's going to be a huge issue, and I'll show you. If you put this in, no, I just can't not do it. All right, I have to put the negative 3 in parentheses. I work with a lot of kids, and a lot of kids don't put this negative 3 in parentheses. So what they're going to do is they're going to do this. They're going to do 4 times negative 3 squared minus 5 times negative 3. All right? And they're going to get this. And they're going to say, well, what the heck? My solution isn't on here. Well, this right here, negative 3 squared, is negative 9. That's because they're squaring the 3 and then they're making it negative. So what we need to do is we need to put that negative 3 in parentheses. All right, negative 3 in parentheses. So I'm going to go ahead and recopy this. I'm going to put that negative 3 here in parentheses. You got to get yourself one of these calculators if you haven't already. They are just a lifesaver. Okay, especially if you know how to use them. If you take AP Statistics, AP Calculus, all right, these are a premium. So if I put the negative 3 in parentheses, notice I screwed that up right there. You got to put this right there, squared, delete this. There we go. I'm going to go ahead and get an answer of 51. D, 51. All right. I'm surprised they don't have negative 21 on there just to mess with you. Okay, I'm surprised. All right, making our way on to number 20. Number 20, let's take a look. All right. Oh, I love the wordy ones. Yeah, right. Okay, we're in the math business because we don't like to read. So, number 20, for all triangles, triangle XYZ, where side XZ, so that's going to be this one, is longer than YZ. Which of the following statements must be true? All right, so they're getting at an axiom where we look at triangles. All right, if the side is longer, that means the angle across from it is, likewise larger. So the larger angle is across from the largest side. The smallest angle is across from the smallest side. So I'm looking for something like, okay, if we know that xz is longer than yz, I bet you we're going to be able to tell that angle y is always bigger than angle x, or something like angle x is always smaller than angle y, just because of the opposite side is going to make the angle open up wider. So if the opposite side is bigger, that's going to make the angle bigger. So let's take a look. F. The measure of angle x is always less than the measure of angle y. Bingo bongo, first one. We didn't even have to read all of them. All right. So use your anticipatory abilities to try to figure out, hey, what are they looking for? What are they getting at? And the only way you know that is if you stick around and do more practice. I always get asked, hey, Math Be Real, Strem, how do you get better at ACT math? Do you know how? More practice. You got it. More practice. So let's take a look at this one. So we've got, here, I'll get this out to the side so I can cover up this one here. I've got the absolute value of 7 times negative 3 plus, check this out. Now, we're going to do this by hand, but if you've got this fancy TI-84CE, you can do math, right, absolute value. Look at that. We can plug it right in. All right, unless there's user error, you're getting this thing right. Okay, 13. And 13 is the correct answer. Okay, so again, I go to math, and then I go all the way to right, and I go to 1. Math absolute value. So here's what we're going to do. Let's do this by hand. So I'm going to do the absolute value. All absolute value means is this is a distance. We don't care what direction. It's a distance. So if my answer is negative 5, then my answer is positive 5 because negative is just the position. Let's say I'm negative, I'm to the left of my position 5 units, so it's negative 5. I know we don't really do that in calculus, we do it a lot more, but absolute value is just a direction and a distance. So I get negative 21 plus 8, so then I get negative 13, absolute value. So what is the distance or the absolute value of negative 13? That's going to be C, positive 13. Okay? How are we doing so far? How's everybody's night going? Good? Fantastic. All right, let's take a look at number 22. Number 22. All right. Now they're hitting us with just some mumbo jumbo, trying to trick us for no good reason because they're bored. All right. If x is greater than the absolute value of y, which of the following is the solution statement for x when y equals negative 4? So it looks like we maybe do something super weird, but in all reality, we just simply need to go ahead and plug in negative 4. Oh, I was going to put negative y there. Negative 4 in for y. So then we get x is greater than, remember, this is just a distance, 4. Okay, x is greater than 4. So my answer is just G. X is greater than 4. Nothing crazy. They're just trying to trick you. Okay, they're just trying to trick you. All right, how are we doing tonight? Okay, it's a Tuesday. We're up here in Wisconsin. It is freezing outside. All right, can't wait till March comes. Come March comes golf. Ugh, love golf. Now let's take a look at this one. The perimeter of a parallelogram is 72 inches. All right, so all right, so let's draw a parallelogram. All right, so we talked about parallelogram last night. If you were here with us last night, fantastic for you, loyal live follower here. We are going to look at a parallelogram's features, which includes opposite sides are congruent and parallel. All right, opposite sides congruent and parallel. Think of it kind of like a rectangle that's been kind of smushed. Okay, a rectangle that's been smushed. So it says the perimeter of a parallelogram is 72 inches. So perimeter is when I add up all the sides. Okay, so the perimeter is when I add up all the sides. All right, so it says One side measure length is 12. What are the lengths in the other 3 sides? So if this is 12, then I know this is 12. All right, so that eliminates E. Okay, we can determine this. So what I can do here is I can say, okay, if the perimeter is 72, and I know that I've got 2 sides that are already 12, I'm left with 48 left for the remaining 2 sides. Now, because I have 48 left, I'm going to go ahead and divide that by 2 different sides. So each side here is 24. So this is 24, and this side is 24. So my answer is 12, 12, 24, and 24. Letter C. All right, how we doing? Are you going to be crushing it here? ACT in Wisconsin at our school is May 11th. Sorry, March 11th, not May. March 11th. Some of you are taking on Saturday. All right, some of you are taking on Saturday, and so you're crunching last minute. Better than nothing, Isaac? All right, the length of the corresponding sides of 2 similar right triangles are the ratio of 2. Okay, so this right here can get confusing for students. All this means is if the smaller one is 2, all right, the bigger one is 5. So it's kind of like if you multiply the small, whatever it is, we can do angle side, not angle because they're the same angles, but if we multiply one side by 2.5, that will go ahead and get us the bigger triangle because the ratio is 2 to 5. So a lot of times these are set up in proportions. So let's just draw these 2 triangles. All right. So 2 similar triangles means they have the same angles, corresponding angles, degrees-wise. And it says if the hypotenuse of a smaller is 5, what would this one be? So we're going to set up what we call a proportion. Proportion is just when 2 equations are equal to each other. So if our proportion is 2 to 5, small to big, and notice how they use 5 here and 5 here, they're trying to trick you. So if I've got 2 to 5, then what is, how many inches long is the hypotenuse larger? So the small is 2, the big is 5. So the small hypotenuse is 5, and we don't know what the large hypotenuse is. All right. So from here, we can go ahead and cross multiply. So 2 times x is 2x equals 5 times 5 is 25. Divide it by 2, and we get x equals 12.5. Okay, you can set up a ratio. Set up a ratio. Another thing is what do I multiply? You can do it like this. What do I multiply 2 by to get 5? Well, you multiply it by 2.5, right? What do I multiply? If I multiply the 5 by 2.5, I'm going to go ahead and get my answer, which is 12.5. Either way works. Either way works. That's what's exciting about math. You've got multiple avenues for success. Math don't discriminate. Remember that. Let's take a look at 25. 25. Oh, look at this answer, B. Hope it's not that one. All right. The sides of a square are 3 centimeters long. One vertex of the square is at 3, 0 on a square coordinate. Okay, so basically, we're on an xy coordinate. We've got 3, 0. Which of the following points could be a vertex? So basically, what we've got here is we've got a square where it's 1, 2, 3 right here, and that's at 3, 0. We know the side lengths are 3, so what we got to figure out is okay, which of these is a possible corner of our square? Maybe this just looks too confusing. I don't want to look at it. -3. So -3 would be way over here. Nope, that'd be a 6 side length. -0, -2, 0, -2. Does 3 squared plus 2 squared, equal 9? No, I don't think so. So I'm going to start here with A, 6, 0. Well, if I go with 4, 5, 6, 6, 0. Is this side length 3? It is. So this one's kind of easy because they gave you A right away. This was kind of a guess and check. Do your best, and here we go. All right, moving on to 26. 26, this may be the hardest problem we're going to do today, kind of depending on where you're at. I feel like sometimes the wordier problems are harder for students or for people in general, not because they're hard, but just because you got to do all that reading and decipher what it's talking about. All right, in this circle shown below, M is the center of a circle and lies on RU and ST. Which of the following statements is not true? All right, so we're looking for false statements. So TUM measures 65 degrees. So TUM is measured 65 degrees. All right, so because we have radii right here, it goes from the center of the circle all the way to the outside. These are radii. These are all going to be congruent, okay? Radii of a circle are congruent. And because we have congruent radii, we have what we call isosceles triangles. All right, how many of you did proofs in geometry class? Oh, I bet you loved proofs. If we have isosceles triangles, then we have base angles congruent. So if we have isosceles triangles and these base angles down here are congruent. So this right here is going to be congruent to this angle right here and all the way over here. These are all going to be the same angle. Now this angle right here is 50 degrees. This angle is also going to be 50 degrees because those are what we call vertical angles. All right, vertical angles. We're still trying to find the measure of TUM. So what I'm going to do is I'm going to take the angle sum theorem, which says that all the angles inside of a triangle, all right, add up to 180, and I'm going to subtract 50, all right, because that's my angle right there. I get 130. So from there, I got to divide that up amongst two separate angles. So then I get 65. So that means these angles down here are 65 degrees. So I know this one's true. I can't do that one. What about G? TU is parallel to RS. All right, so because these are all equal length, that means that I am going to have parallel segments here. So that one is true. All right. The arc TXU is going to measure 50 degrees. This is correct. So when you have points on a circle like this, and then they join an angle here at the center, this angle measure is going to be equal to the arc measure. Okay, so the arc measure is a proportion over 360 degrees. So this would be 50 degrees. So that one is true. RM is congruent to TM. We've already discussed that that one is true because those are radii. So we're left with RS is congruent to SM. Yeah, there's no indication that those two are the same. Could they be? Sure, but not in this situation because the only way RS and SM is congruent is if all of these angles were equal. If they were all 60 degrees. Then we'd have an equilateral triangle. We don't have that, so K is false. Hey, I told you that one was the hardest. Shaden, good to have you on board. Okay, so that one was probably the hardest we're going to go through tonight. All right, here we go. John Jones. I had a guy I played football with, John Jones, good guy. John Jones has decided to go into the business of producing and selling boats. Okay, boats. In order to begin this venture, he must invest $10 million in a boat production plant. The cost to produce each boat will be $7,000. All right, so how much money does he lose? He loses $7,000 per boat. Okay, probably should be writing that in red pen. And he also loses $10 million. Hey, I lost $10 million in a crayon company last week, but hey, you know what? I'm still surviving. I do gain $20,000 every time I sell a boat. All right? Every time I sell a boat. So this negative 10,000 right here, this is just going to be a net loss. All right? There's no variable attached to that. So I'm guessing it's going to be A or B. All right? I feel like Mark Cuban over here in Shark Tank. So I've got 20K going up, 7K going down. That gives me a difference of 13. So I make 13K per boat minus my 10 million initial investment. All right, so that's letter A. Letter A. All right, let's take a look at the next one. We've got if 2x squared plus 6x equals 36, what are the possible values for x? All right, this is a straight up algebra problem. All right, those of you who are currently in school, this one probably isn't terribly difficult. For those of you who are not, stick around. All right, so we've got 2x squared plus 6x equals 36. Now, this is a quadratic. This is a parabola, which means I need to solve this using my zero product property. I need to find the x-intercepts, the solutions, the zeros. So what I'm going to do is I'm going to go ahead and subtract the 36. So I've got 2x squared plus 6x minus 36 equals 0. Okay? So from here, again, I'm trying to write this as a product of two factors, so I can use zero product property. Now, I'm going to reduce this. I'm going to divide everything by 2. And the reason I can do that is because I have this equal sign. I had students do it today on a quiz. They had an expression. They just had this. And they divided it by 2. Can't do that. Got to have that equal sign. So now I have x squared plus 6x, plus 3x, because I divided it by 2, minus 18 equals 0. So now what I'm going to do is I'm going to go ahead and I'm going to factor this. How we factor this is we write this as a product of two binomials. Okay, some of you might have learned FOIL, some of you might have done an area technique. So basically what I'm going to do is I'm going to go ahead and figure out, all right, if I FOIL out all of these terms, if I multiply all this out, I want these two factors to equal x squared plus 3x minus 18. So in essence, what two numbers multiply to negative 18 but add to 3? Okay, multiply to 18 but add to 3. All right, so the answer is positive 6 and negative 3. They multiply to negative 18, they add to 3, I'm good to go. So what I need to do is I need to use zero product property. So a lot of times we kind of skim over like what is zero product property. So zero product property basically says if I have some multiplication between two terms and it equals 0, I don't care if they're parentheses, I don't care if they're exponents. If one of them equals 0, if a equals 0, that means that the whole thing is 0. Or if the b equals 0, then the whole thing is 0. So basically, if I just set the two terms equal to 0, both are solutions. So that's what I'm doing here. And then this is just a simple minus 6. So x equals negative 6. And then this is plus 3. So x equals 3. So my two solutions for x are 3 and negative 6. That would be G. All right. Might be easy for some of you. All right, no big deal. Start easy. Tomorrow and Thursdays will be harder because we'll be doing the back end of the test. All right, here we go. As a class experiment, a cart was rolled at a constant rate along a straight line. This reminds me of a calculus problem. We have a lot of calculus problems like this with this chart. Sean recorded in the chart below the distance in feet with regards to time. Which of the following represents this data? So if I take a look at my t values, okay, we use t values. If you have an x and a y, we call that a parametric equation. So it looks like the x values, or the t values, are going up by 1. All right, that's good. That allows me to see the relationship between our response variable or our output is just plus 4 every time. This gives me a linear equation, all right, where looks like x is my response variable or my output or my independent variable equals 4, which is my slope. I'm going up 4 every time. My rate of change, probably better. 4 times the time, all right, plus 10. So 10 is my starting point when t equals 0. So when t is 0, my starting point is 10. My rate of change is 4, so that leaves me with C. All right, leaves me with C. All right, let's take a look at number 30. Number 30. All right, I'm gonna set this up here. Okay, I know a couple of you are watching. I want you to try to do this one on your own. This one's a little bit tricky, takes a little bit of thought. So to increase the mean is the average. All right, the average is when you add them all up and divide by how many there are. Okay, to increase the mean of 4 numbers by 2, how much would the sum of the 4 numbers have to increase? What do you think? Okay, I'm going to give you about 15 seconds. Okay, that is correct. That is correct. I was wondering why they called you Sean. So if I go ahead and take the mean of 4 numbers, attaboy Snyder. If I take the mean of 4 numbers, all right, so if I take 8 plus 8 plus 8 plus 8 is 32, divided by 4, okay, that's going to give me 8, right? That's my average. If I want to make this average to be 10, I need this to be 40. So in order for this to be 40, I would have to increase by 8, all right? So that's going to be J. All right, 2 more left, 2 more left. All right, we've got Meg. Meg pounded a stake into the ground. I'm sure she did. When she attaches a leash to both the stake and her dog's collar, the dog could reach 9 feet from the stake in any direction. Using 3.14 pi for pi, which I absolutely hate, but that's ACT, we'll follow their rules. What is the approximate area for the lawn in square feet? All right. What do you got? We've got area is pi r squared. They do not give us this. We have to go ahead and memorize that. So if the area is pi r squared, we do 3.14. This problem isn't even hard. Like, they don't even give us the diameter to try to make it a little tricky. They literally say the dog's leash is 9 feet from the stake. So we go ahead and we put 9 and we square it. All right, so we've got 3.14 times 9 squared. Okay, 254.34. I got to ask for the approximate, so that is going to be D. All right, here's the deal. If you plan on taking math in your future, especially if you're thinking about having any math in your career in college, please purchase a TI-84 Plus calculator. It will be worth it. Number 32. Television screen sizes are the diagonal length of the rectangular screen. Hector recently changed from watching a television with a 13-inch screen to a television with a similar 19-inch screen. If a boxcar appeared 8 inches long on the 13-inch screen, how long is the nearest inch will it appear on the 19-inch screen? Whoa, that's a lot of words. They're obviously trying to get us all rattled. All right, but we're here because we're not going to get rattled. This is going to be one of the easy questions. So this is a basic proportion problem. All right, so we've got 13 to 19. All right, so 13 to 19. Okay, so just to let you know, the diagonal, what it meant is all right, so this right here is 13 inches on a TV. So if this is, 19 inches, and then they're saying, okay, if I've got a box car that is 8 inches long on my TV here, how long is it going to be on my 19-inch screen TV? All right, so it's just a simple proportion. So if this is 13 to 19, if this is 8, how long is it going to be on the 19-inch TV? All right, let's see who's going to put the answer down first. All right, let's do some math there. Okay, who's got it? Who's got it? Who's got it? How big is that boxcar? Who's got it? The answer is going to be 12. So what I do is I basically just do cross multiply 19 times 8 and then divide by 13. So 11.69, which is approximately 12 G. Attaboy, Snyder came in last second. All right. Fantastic, everybody. I'm peacing out for the night. My kids are sick, but I hope you enjoyed this live. Let's join again tomorrow. Peace out.